What's up, guys? Welcome to November 2024 paper 1 grade 12 paper. Today let's have a look at question 1, and then we are gonna stick around to do all the questions up until the last question on this paper, which was question 11 or 10, yeah, but stick around and then we'll do all these questions together. At the end of this video you can click and then there's a playlist where it will take you to question 2, 3, 4 up until the end, and we will upload again also a paper 2 as well. So let's have a look at 1.1 here. It says you need to solve for x from 1.1.1 up until 1.1.5. all right, so now 1.1.1 they want us to solve for x. It says here 1.1.1 says here x and then x minus 3 is equal to 0. Therefore, when you solve for x, simple, straightforward, x is equal to 0, or it's gonna come here and say x is minus 3, it's equal to 0. Therefore, you take 3 to the other side, so x is equal to 3. All right, so those are your values right there. All right, so moving right along, 1.1.2, 1.1.2, it says here 2x squared plus 1 is equals to 4x. It says here solve for x correct to 2 decimal places. You know, when they ask you for 2 decimal places, they are asking you to use what? A quadratic formula to solve for this. They are asking you to use a quadratic formula to solve for this. All right, so let's go ahead and see what we can do here. So we need to take this 4 to the other side, so it's going to be 2x squared. Take 4 to the other side. I'm just gonna say minus 4x plus 1 is equal to 0. So now therefore what you have here, you've got a, therefore this is minus 4 is equal to b, and then here it's equal to c. So therefore our formula says that x is equal to minus b plus or minus square root of b squared minus 4a all over 2a, minus 4ac all over 2a. So therefore we need to substitute this numbers here into this equation. So we're just gonna come here, I'm gonna continue up here. X is equals to minus b, which says here it's equals to minus, therefore b is what? It's minus 4, close, therefore plus or minus square root of b, which is minus 4 all squared, minus 4. A is what? A is equal to 2, and then what is c? Thank you very much. If you said c, it's 1, and then all over 2 into 2a. So a is what? It's also equal to 2. So I'm just gonna jump right away into my calculator. If you've got a Casio calculator, guys, you can put this all together here. I'm expecting you, because you are in grade 12 by now, you should know what to do here. The other one will be plus, then you will change the sign and put a negative. So I have randomly done that, and then what I found is that x is equal to 1.71, or x is equal to 0.29. all right, so if you got a different answer from the one I got, please let me know on the comment section below. Maybe I'm the one who made a mistake, or you made a mistake, we did it differently. So please let me know what you guys think on this one. So moving right along to 1.1.3, 1.1.3, it says here it's an inequality 2x minus 2x minus 3 greater than 0, right? So therefore here in this one we're gonna go straight away and look for critical values, because already it means now we're gonna write 2x squared minus 2x minus 3 should be equal to 0. We are looking for the factors that when you multiply together they give us minus 3. We know that is going to be 3 and 1, so they just have to be negative and positive. There you go. So our critical values is going to x is equal to minus 1, or x is equal to 3. So now here we have got these critical values. Now let's have a look at the solution. Then we're gonna have two possible solutions using our inequality sign. Either our value will lie between -1 and 3. If it's in between, you're going to express it like this. It's going to be x greater than -1 or x less than 3. Or if it's lying outside, so it means our value will have to be x less than -1 or x greater than 3. So now what do you do in this case? So in this case, in order to find out which one is correct between these two, these are the two possible solutions that are there. Or guys, you can use the diagram, others, but basically just use whatever you prefer in this instant. So for me now, I prefer using this one because I know that the solution has to either be between these two values, or it can be outside the two values. So now in between here, we can choose which number is in between. I can choose 2. So we're gonna choose 2, and then we substitute 2 there. All right, if we put 2 here on this here, let's see if we put 2, the answer we're going to get will be greater than 0. If not, therefore this is not the solution. The other one will therefore be the solution. So if you were to put here, you're going to have 2 squared here, which is going to give us, let me use a different color to illustrate this so that you guys can easily follow. We are going to have 2. I'm putting 2 here. 2 squared is going to give me 4. 2 times 2 is going to give us 4, and then -3. So what do you have here? Our answer is -3. -3 is not greater than 0. Therefore, this can be the solution. So this 4 is not the solution. So our solution will therefore be this one here. You can do it like that, or you can use the number line, whichever way you prefer, guys. I prefer using this one because it's much easier and simpler. Then you just choose the solution. Therefore, on your paper you can write 1, or you can do this one on your question paper, then you write the correct answer thereof. Right, so now let's go to 1.1.4, which is this one here. It's an already when you see this one, you know guys, this is an exponent. Therefore we need to solve for x on this exponent, which is 2 to the power of 2x minus 2 to the power of x plus 2 minus 2 is equals to 0. So therefore what you need to do here, you need to break this apart, because now 2 to the power of x all to the power of 2 is going to be minus 2 to the power of x, which before it was like that, then you need to separate them. Minus 32, you're gonna leave it like that because minus 32, it is just a constant, so you leave it like that. So now if you see here, what is inside here is 2 to the power of x, then you've got 2 to the power of x there as well. So therefore these two, you can therefore easily say let 2 to the power of x be equal to k. So now you're gonna put k there. On this one is going to be k squared minus 2 to the power of 2 squared is giving us 4, and then here in space of 2 to the power of x, you're gonna put k minus 32 is equal to 0. Now you look for the factors. When you multiply them together, they give you 32. Okay guys, if you are in grade 12 by now, you should really know how to factorize. So therefore here you are going to have k, you're going to have k, so therefore 8 times 4 will give you 32. So you're going to have minus 32 here, minus 4 there. Oh, sorry, plus 4. Therefore k is going to be equals to 8, or k is going to be equals to -4. So therefore in this case you need to substitute back the 2 to the power of x into here. So you're going to have 2 to the power of x. Then if you change this 8 to make it the power of 3, you're going to have 2 to the power of 3. And we know here that there's no way that 2 to the power of x can be a negative number. So therefore this one won't work for us. Then we know that x is equal to 3. All right. So that's how you would deal with this exponent one. Immediately when you see exponent, guys, just think of using k. Think of what? Using k. All right. So let's move on to the last question, which is 1.3. 1.5 rather. I mean to say here it's a square root, guys. I know it's not it's not that visible, so we're busy with this question right here, 1.15. So therefore it is equal to square root of negative 2x plus 4 minus x is equal to 2. Therefore, what you need to do here, we can already see that what we have here is a square root, so we need to eliminate the square root. So we're going to isolate the square root and put it on its own, or put the square root alone. So we're going to take negative x to that side. Therefore, this side we're going to be left with the square root minus 2x plus 4. All of them inside the square root is equals to x 2 plus x. So therefore, we need to square both sides. Square both sides. This side is going to remove the square root. We're going to be left with a 2x plus negative 2x plus 4 is equal to, here we need to remove the bracket, guys. So I'm just gonna randomly do this together. Even if you write it like this, guys, it will still be the same because there is no a negative number here. So if it's like that, you can say x times x equals to x squared plus x times 2 is going to be 2x, and then 2x plus 2x is going to give us 4x, and then 2 times 2 is going to give us positive 4. So therefore, in this case, you take everything to the right hand side, so x squared will remain as s squared. Then if you take this negative 2x to that side, is going to be plus 4, which is going to be give us 6x, and then now you're going to be left with this 4. When it goes that side, it's going to be negative 4, which is going to be equal to 0. Because why? This one goes that side is going to be negative, and then it's going to minus this 4 that is sitting here. If I'm moving a little bit too fast, guys, but if you don't understand, let me know on the comment section below, or do it step by step, because I'm a little bit jumping steps here, but I'm only doing that because I don't have space to write on here. But I hope that doesn't cause any confusion on your side. All right, so therefore here we're going to take out a common factor of x. We're going to be left with x plus 6 is equal to 0. This means that x is equal to 0, or x is going to be equal to negative 6. Therefore, now if you have a square root and you calculate the values of x, remember we have squared this to remove the square root before. It means we have changed the original equation. Therefore, the x values that we found, not all of them will satisfy the equation that was given initially. All right, so what do we do in this case? We need to substitute it back into the original equation and check if the equation will be satisfied. In other words, what I mean to say is that if you put 0 here, will it give you 2? Or if you put negative 6 here, will you get 2 or not? You will see that if you put 0 here, you will get the answer 2. Because now you're gonna say negative 2x times 0 is going to be 0, square root of 4 is going to be 2, and then minus 0, which is equal to 2. So therefore this will be the solution. However, unfortunately, x is equal to negative 6 fixed will not be the solution. So you must put it like that and let them know that x cannot be equal to negative 6. Right, now let's move right along to 1.2. Okay. All right, guys, here we go. There's a 1.2 here. It says solve for x and y simultaneously. So now if we have a look at this equation here, we have got two equations: 2x plus y is equals to 3, and y squared plus x and y is equals to 2. So therefore this could be equation 1, this could be equation 2. It makes life easy for you to mark them, but if you don't, it is also fine. So y is equal to 3, then you take this 2x to that side is going to be minus 2x, which gives us equation 3 in this case. So therefore you take equation 3, then you substitute it into equation number 2. Right, great stuff. So now if you have that, you're going to say y squared plus x and y is equal to 2. Then you take this y, you put it here. Wherever there's y, you put that y there. So therefore this simply means you're gonna have 3 minus 2x all squared plus x into 3 minus 2x all close equals to 2. right? So therefore now we need to remove the bracket here. This, when you remove the bracket, we need to expand this. In this case, we're gonna expand this into 3 minus 2 close. Therefore we're going to have x times 3 is going to give us 3x. X times that is going to give us minus 2x squared. I might as well take these 2 to this side, which is going to give us negative 2 is equal to 0. Therefore now here, when you remove the bracket, 3 times 3 is going to give us 9. 3 times negative 2x is going to give us negative 6x, and another negative 6x here, which when you add together will give us negative 12x. Therefore negative times negative, positive. 2 times 2, 4. Then x times x is going to give us x squared. Therefore what we left with here is just to simplify this. So therefore when we simplify this, we've got 4x squared here minus 2x. We're going to be left with 2x squared, and then we've got negative 12x here plus 3 is going to give us negative 9x, and then also we've got 9 here minus 2. This should give me plus 7 in this case is equal to 0. Therefore we need to factorize this here is equals to 0. If you factorize, it's going to be 2x and then x, then you're going to have 7 there and a 1 here, and then the other one needs to be positive or negative. Both of them needs to be negative. Here you go. Let me see. Right, there you go. So therefore x can be either 7 over 2 or x can be equal to 1. Now what do we do in this case? We need to go back into equation number 3 to find the values of x that correspond with the values of y rather that correspond with each value of x. Therefore we're going to say y is equals to 3 minus 2 into 7 over 2, or y is equals to 3 minus 2 into 1. Okay, therefore here in this case you are going to have y is equal to, if you take that out, 2 and 2 would cancel out. 3 minus 7 is going to give us minus 4, or y is equal to 1. Okay, great stuff. And that's how you deal with a question like this one when it comes to simultaneous equation. So moving right along, let's move on and come to a very interesting question of 3.1. 3.1 here, it says that consider a product which is given in this case by 1 plus 1 over 2 multiplied by 1 plus 1 over 3 multiplied by 1 plus 1 over 4. And then they say that each factor in the product is of the form of 1 plus 1 over n, where n is greater than 2. So which is very interesting. We're going to deal with this one. Now they say that determine all the values of n for which the product will be an integer value. Okay, so we need to determine all the values of n where it will be an integer. So what are you looking for in this case? An integer in this case, you are looking for any value that when we simplify this equation, we need to see that this value can be divided by 2 for all the values that are greater than 2. So now what do we do in this case? Let's see. Let's just come here and put this down here for the sake of understanding. Please guys, don't let questions like this one scare you. If you feel like they're gonna waste your time in terms of thinking, please just leave the question and move on to the other questions, and then you will come back to this one once you have got time. All right, so n needs to be greater or equal to 2. So now in this case, when you simplify this, put this in your calculator. 1 plus 1 over 2, this will give us 3 over 2. Therefore in brackets, this one will give us 4 over 3, and then this one will give us 5 over 4, and then it continues thereof to go on and on and on and on. So what do you see here? What you see here, guys, is that if you were to simplify the last term here in this case, the term here that continues to go on and on and on, let me remove this so that you guys can see it goes on and on and on, is going to end up in this situation right here over n. So now what happens here when it goes on and on? What you are going to have, n plus 1 all over n, which is our last digit or also our last product there at the end. So now in a case like this, what do you do now? So you will see here, guys, that the number or the number of the product that comes before this one here, okay, because if you ever look at this one, for this one to come here, it needs to be -1. If I were to say go back to this one, you're going to say what? 3 minus 1, it will give us 2. Then you're going to say 4 minus 1 is going to give us 3. So therefore it means the number that comes here has to be n minus 1. Okay, I hope that is clear in this case. All right, so now what do you do? The one at the top, what is happening? You are adding 1 every time. 3 plus 1, 4. 3 plus 1, 4. So therefore in order to go backwards, you need to minus 1 again. All right, so now what would happen here? It will say over n minus 1 but plus 1 here. Okay, great stuff. So now having that in mind, guys, I want you to look at something here. If you ever look at all these numbers here that we wrote down here, if you ever look at here, these numbers, if I were to say simplify this, you would come here and say 3 and 3 would cancel out, 4 and 4 would cancel out. It means here when you continue, 5 and 5 would cancel out, just like that. And then here also you can see that here you would say what? You would say n and n, because this one gives you n. -1 and -1 cancel, n and n would cancel out. So can you see, guys, what are you left with here? Can you see? So similarly, the same like that. So in the numbers here, you're going to be left with 1 over 2. And then in terms of n, you are going to only be left with n plus 1. Okay. So after cancelling out, you are going to be left with n plus 1. So now in order determine the n value for which the product will be an integer. In order for this number to be a whole number, remember an integer, you're looking for a whole number, you are not looking for the fraction, guys. So in order for you to have a whole number here, what must happen? The numbers of n here must ensure that this product here, when you divide by 2, it gives you a whole number. So what do? Let's say for an example, you say if, I just want you to put this into test. If n is equals to 3, what do you have? 3 plus 1 is equals to 4. 4 divided by 2 is equals to 2. All right. So if you were to say n is equals to 4, remember they said n has to be greater than 2. So if you say n is equals to 4, what are you going to have? You're going to have 5 here. You're going to say 4 plus 1, which is equals to 5, and that's not what you're looking for, because you won't be able to divide by 2. So you're looking for all the n numbers that makes this product to be divisible by 2. So which is what here? If you put 5, can you see? If you put what? So now what does this mean? This means that now everything, all your n values has to be an odd number. So therefore, in order for this to pass up until infinity, n must be an odd number. So n can be any value, but it needs to be an odd number. Therefore this will make the product to be a even number. Therefore this product here, I mean this here, is going to be an even number. Therefore it's going to be able to be divided by 2. So that's how you would deal with a question like this one here, guys. So you can just say n must be an odd number up until infinity, therefore to ensure that the product can be divided by 2, and therefore it will make this n integer. I am Gaston Mapala. This was question 1. Let me see you in question 2. Now let's go to question 2. Question 2, it reads as followed. The first term of an arithmetic sequence is 7. So therefore it means a is equals to 7. Then the common difference of the series is 5. So therefore it means d here is equals to 5, and the series contain 20 terms. So therefore our n there is going to be equal to 20. Right? So 2.1.1, it says that calculate the sum of these series. Okay, so now to get the sum of this series, because it's an arithmetic series, you know that we use the formula 2.1.1. we're going to use the formula Sn is equals to n all over 2 bracket 2a plus n minus 1 d, therefore close bracket. So we already have a, we already know what is a, so we're looking for s 20, sum of 20, n is equals to 20 over 2 bracket 2a, it's what, a it's 7, close, plus, let me just write clearly there, plus 20 minus 1, close bracket, then our common difference is equals to 5, therefore close. Therefore, when I put this into my calculator, you can pause the video, guys, and put it in your calculator as well to check if you will get the same answer as me. I am getting 1090. Okay, and that's how you would deal with question 2.1.1. Easy, straightforward, just following the basics. All right, so now let's come to 2.1.2. 2.1.2 says that the original arithmetic sequence is extended to 70. So it means here n is 75 to 75 terms. The sum of these 75 terms is equals to that. So it means now this is s 75 terms. Using sigma notation, write down an equation for the sum of the terms added to the original term. So now it means the sum of this m added to the original term. Remember, the original one was what? Was s20. So now something was added here, added to get us to sum of 75. So you want to know what is added here in between. So therefore the difference between these two should give you what is added here in between. So therefore it means now what is added is going to be given by sum 75 minus sum at 20. Okay, which will give us sum 75. They already told us it's 114,400 minus 109,0. So this gives us how much? This will give us the sum that is added is going to give us 13,310. So this is what is being added. However, what are they saying? They want us, it said, you're using sigma notation, write down the equation. So now they want us to use sigma what? Notation. Right. So now let's go ahead and find the formulae of these terms. Remember, this is an arithmetic sequence, so the formula that you're going to find, we're going to use Tn is equal to a plus n minus 1 equals bracket d. So therefore you know what is the first term. The first term is 7 plus n. Here we're looking for the nth term, which is the general formula, and then the difference between the terms is 5. So therefore you can simplify this, say 7 plus 5n minus 5, which will give us 5n is going to be plus 2. So therefore this should be our Tn. All right, so therefore it means now we can express this in terms of sigma notation, because now we already have. And sigma notation, what do we have? So if we were to write this in sigma notation, we want to have to start from where? Remember, we are looking for what is in between these two things here. So it means Sn here, what was 20, so we're looking for Sn 21. We're gonna start from 21. Gonna start from 21 up until 75. So therefore it means here our n value here, we must start at 21 and then up until where? 75. Guys, I hope you still remember sigma notation. You did it in grade 11. So this is how you would express it. You are starting to calculate here up until the end here at 75. What, using which formula? Using this formula 5n plus 2 close bracket. Then our sum will have to be 13. Remember, this is the sum of what is added. So this is how you would express this in terms of sigma notation. All right, so if you've got any questions, guys, please let me know in the comment section below. I am Gaston Bampala. Welcome to Maths with Gaston. If you have not subscribed, please subscribe. We do content concerning mathematics from grade 10 and also grade up until grade 12. So let's move on to 2.2. Okay, so 2.2 says here the sequence of the first difference of a quadratic pattern is given by that. Okay, so I hope that is very clear. So basically, what does this mean? Just to explain this question here, this means that what do you have? You have got term 1, term 2, which is a quadratic, term 3, and then you also got term 4 here. So when you take the difference of these terms, you get 1. You take the difference of these terms, you get 3. You take the difference of these terms, you get 5. Okay, and therefore clearly here you're going to get 2. Therefore here also you're going to get 2. So basically this is what it means here. This is the first difference of the quadratic pattern. It gives us this pattern right here. All right, so let's go on. 2.2.1. It says if T99 of this quadratic pattern is given by that, calculate T98. Okay, so now here, guys, you need to think very carefully about this one. What you need to do, they are saying if T99 of a quadratic pattern, it means you have gone around here and then you get to T99, 98 here, and then also T99 somewhere there. So they are saying T99 of this pattern, it is given by 9, 6, 32. So now they want you to find this one. So it means here in arithmetic sequence you must have got, because this is T1, 2, 3, 4. So it means here in arithmetic sequence this year should be T98. So it means what you can do, you can say T98 minus that will give you this value here. Okay, I hope it's clear, guys, because in order for you to get this one here, T4 minus T3 gives you this one. So in order for you to go back, you must say T4 minus that, it will give you T3. Okay, so now how should I illustrate this? Oh yes. Okay, it means here now what you can do, you can go and find the formula of arithmetic. Okay, because we know that a here it's equal to 1, and then the difference there is equal to 2. So therefore T98, when you have to find this term here of arithmetic sequence, is going to be given by, you're going to use this formula here. Okay, first term is 1, and then T98 minus 1, and then D is equal to 2. So therefore T98 of arithmetic sequence. Okay, guys, this is for arithmetic sequence, not for quadratic, because for quadratic we have got nothing that is given there. So this will give us, if I put this in my calculator, is giving me 195. Okay, so it means it is 195 for arithmetic. So it means here the number here is what? 195. So what do you do with that 195? To go back here, to go backwards here, you need to minus this 195. So you're gonna come here and say therefore T98 for quadratic now is going to be equals to T99 for quadratic minus T98 from arithmetic, the one we just calculated now, which is this one, the one for arithmetic, guys. Don't forget. Okay, don't get confused between these two, guys. Don't get confused at all. Okay, all right, so T99 is going to be 9, 6, 32 minus, and then the one for arithmetic, which is 195. Therefore it gives us T98 for the quadratic is going to give us I'm getting 9, 4, 37. Okay, great stuff. Okay, and that's how you would deal with a question like this one, guys. Moving right along, let's move on to 2.2.2. right? So 2.2.2, it says here, if, okay, if it is further given that the third term of the quadratic pattern is 34. Okay, the third term, okay, they are saying this is T3, the third term, it's equals to 32. Determine the general term of the quadratic pattern. Okay, they want us to find the formula for the quadratic pattern. Okay, so what you would do here, you already know that if you are given something like this with the pattern, if you are given something like this with the pattern, if they said what? The third term is 32. Oh, okay. If they have given us 32, let me see. 3, 5. If they say the third term is 32, okay, T1, T2, okay, T3. This minus that will give us 1. This, okay, I'm doing this wrong. Okay, let me just figure it out here, guys. I'm just going to check something. Okay, here we go. Let's see, T1, T2, T3, and therefore T4, and then we are summarizing this now, gives us 1, T minus DT gives us 3, therefore this minus that gives us 5. Okay, so now they've given us this one here. They are saying this is 32, so this plus this 32 minus 3, 32 minus 3 should give us term 2. Okay, guys, now here you are just working backwards to go find the other terms here, so that you will be able to use this here, right here. You're gonna have 2 there. Common difference here is 2. So if they say the third term of the quadratic pattern is 32, so you need to go backwards. This one minus 3 should give us how much? Okay, so it's 32 minus 3 is giving us 29. There is 29 from 32, therefore this one minus 1 is going to give us 28. Okay, great. Okay, so with that, now we can come here and say, remember guys, this, it's, you must know by heart. Okay, you must know that this, the common difference is equals to 2a, and then therefore the first term of the first difference is given by 3a plus b, it's equals to that, and therefore a plus b plus c, it's equals to that term there. Okay, so now let's see, let's go ahead. 2a is equals to 2 divided by 2 divided by 2, therefore a, it's equals to 1. Oh, I'm forgetting something, guys. The quadratic equation formula generally is supposed to be Tn, it's equals to an squared plus bn plus c. This is what we're looking for basically. So we need to look for a, we need to look for b, we need to look for c as well. All right, so we already got a there. Let's continue. 3a plus b is equals to 1, plus b is equals to 1. So we know that here plus b is equals to 1. Okay, so now with that, take b, take 3 to that side, you're going to have a 1 minus 3, which gives us b is equals to minus 2. Great. So now to find a, you're gonna come here, use this one here. You're going to say a plus b plus c, it equals to term number 1, which is what, 28 in this case. So a, we already know a is equals to 1, b it's minus 1 plus c, it's equals to 28. Therefore you're going to have minus 1 plus c, it's equals to 28 here. Therefore take 1 to the other side, c it's equal to 28 plus 1, which is equals to 29. Okay, so therefore it means we can come here and substitute this into our formula. Therefore Tn is equal to a squared minus 2n plus 29. This would be our general formula, guys. So you can check our general formula by substituting term 99 to see if you are going to get 9632. All right, and that will be all for question 2. I am Gaston Mapala. Let me see you in question 3. Interesting question indeed. Make sure that you subscribe, share this video with your friends, your family, your cousins, and also your classmates. Guys, thanks for clicking on question 3. So here is question 3. It reads as follows: a circle with radius 6 centimeters is drawn. A second circle smaller is drawn through the center of the first circle. Okay, so it means the first circle, when it's drawn, the radius of the first circle, it means it's the bigger one, this one. Okay, because they are saying the second one it's smaller, so it means the first one is this one, the second one is this one, the third one will therefore be this one. Okay, so they are saying a circle is drawn with a radius of 6, so it means from here to there it's 6 centimeters, so therefore this is the radius. Okay, and then through the center of the first circle and also touches the first circle internally. Okay, there you go, as shown in the diagram. A third circle is drawn through the center of the second one, so a third one is this one, through the center of the third one and touches the center and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay, because guys, immediately when they say geometric pattern, you must know that you will be using Tn, it's equals to Arn minus 1, and then also you'll be using Sn, it's equal to Arn minus 1 close bracket all over R minus 1. These are some of the things, and then you would have to determine the ratio, which is given by T3 over T2, which must be equal to T2 all over T1. Okay, great stuff. So therefore let's go 3.1. I hope we understood the question, guys. I hope we're together here. 3.1 said write down the radius of the third circle. Okay, so now if the first one is 6 centimeters, the question says it's drawn and then touches internally. So it means the radius of this one, of the second circle, is just half of this one. So it's just going to be half of this one, which is 6 divided by 2 is 3. And then you have this one here, which is going to be half of this one. Okay, so the radius will be somewhere there, which is going to be half of 3 divided by 2 is going to give us 3 over 2. Okay, makes sense, guys? Makes sense. All right, so now they said we need to determine the radius of the third circle, so it's just going to be 3 over 2. Okay, all right. 3.2 says calculate the sum of the areas of the first 10 circles. Okay, so basically this means that our n needs to be 10 And then what are they saying? They are saying the sum. So it means we need to find Sn. Okay. So but now what happens here when you are looking for these circles? Okay. So if we have a look at this one, let's see what happens. So they are saying the sum of the area, sum of areas. So sum of areas, what is the area here? The area of a circle is what? Is pi r squared. Okay, let's say this is for circle number 1 plus that of pi r squared, circle number 2 plus that of pi r squared, circle number 3, and they're on up until pi r squared, circle number 10. Okay, so now if you have a look at here, guys, we have got a common factor here, which is pi. So what we can do here, we can take out a common factor of pi from this pattern or sequence. You see now it has formed a pattern, guys. Like they said, it's a geometric pattern. 1 squared plus these r, you can't take them out, guys, because they are not the same. Remember, r changes every time. Okay, so there we go. We take out this common factor. We take out the common factor of pi. So this is what we're gonna be left with, r squared 10. There you go. So now if you see there, what are we left? We're left with that. So it means basically what we are left with, if we can substitute r, let's come here and see the type of a pattern that is formed. Okay, now we're focusing on the type of pattern because we have taken out that. The type of pattern that is formed here is formed by r1, okay, squared, r2 squared, r3 squared. Okay, so now let's substitute r1. The first radius is what? Is 6 squared. Then the second radius is what? Is 3 squared. Then the second radius is 3 over 2 all squared. Okay, there you go, guys. Remember, what are we getting? We're getting this from these radiuses that are sitting here. Okay, but remember, this does not give us the ratio, only gives us the pattern. So we've got T1, T2 and T3. So therefore, what is the ratio now? The ratio of this pattern is going to be given by T3 over T2 there, it's here. T3 over T2, which is T3 is that one, is 3 over 2 all squared all over 3 squared, should be equal to T2, which is this one here, over T1. T2 is 3 squared all over 6 squared. So if you were to put this in your calculator, you would realize that the ratio is going to be 9 over 36 is our ratio. Okay, so now what does the question say? The question says we need to find the sum of the areas. So now we can come and find the sum of the pattern of the radius. Okay, so now remember our formula here, we still have to put back this thing here into this equation here, but I will show you just now in case you're confused. Let's see. So we're gonna use which one? We're gonna use this formula here. We're gonna come here and say Sn is equals to Rn minus 1 all over R minus 1. So what do we have here? We have got A is what? A is this first term here, guys. Remember we said we're doing a pattern, so first term is 6 squared. So 6 squared is our first term. And then R is what? It's, put a square bracket here. R is what? R it's 9 over 36 all to the power of 10 minus 1 close bracket all over 9 all over 36 minus 1. Okay, so we punch this together in our calculator. We punch everything. I can see that now I am found in 47.99. okay, so now this is our sum. However, we need to substitute back this sum into this equation here. Remember they said sum of the areas. So now what can we do in this case? We can say, okay, now therefore sum of the areas is going to be equals to sum of the areas is going to be equals to pi, and then sum of that is pi what? 47.99. So that will be our answer, guys. All right, so we can therefore, but however, we're not done, guys. Remember, this is given in what? In terms of, it is given in terms of centimeters. Okay, so we can say here the answer will be pi 48 centimeter squared. If you don't put centimeter squared, that you're gonna lose a mark or half a mark. Okay, so I hope you understood this, guys. Looks a little bit scary when you look at it from the beginning, but when you unpack it nicely and follow the basics, you should be okay. All right, so immediately when they say geometric sequence, put all the formulas that you're going to need there, so that when you continue, you know exactly what you are looking for. Let's move on now to 3.3. 3.3 said, which circle has a diameter of 3/128 centimeters? Okay, let's come this side. Okay, so we already know that the ratio, we calculated it that side, ratio it's 9/36. Okay, our first term is what? Is 6 squared. All right, so what are they asking us? They're asking us to find the circle that has got a diameter of, but remember, we're not working with diameter, so a diameter is equal to we're not looking for diameters. I mean to say, we're looking for radius. So radius is going to be equal to diameter divided by 2, which is going to be 3/128 divided by 2, which gives us an answer of, if we were to put this into our calculator, is going to give me 3/256. So that is our radius. So what do we do now? We know that a geometric pattern uses TNAR minus 1. So we already know this term here. They already given it to us. It is this one, 3/25. What are we looking for? We're looking for n, because we don't know what is n. Okay, so our first term here is what? Our first term here, it's 6. Okay, did I make a mistake? Our first term is not 6 squared, it is 6 squared. Okay, let me just check something here, guys, on my calculator. Our first term should be 6 squared. Okay, like we did it earlier, our first term is 6 squared. R is what? It's 9/36 to the power of n minus 1. No, sorry, to the power of n minus 1, but I'm writing 10 there, n minus 1. So therefore, once you have this, let's see now, you can say 6 squared, right? So now if you were to simplify this, 3n 256 is equals to 36, 936, and then there you go, then it's n minus 1. So therefore you can divide both sides by 36. Remember, guys, you can do that. You can't cancel out like this. No way, you can't do that. Because why? Because this is in bracket and is to the power of n minus 1. All right, great. So now when we come here, we can say, when we come here, we can say 3/256 all divided by 36, all divided by 36. Okay, or we can say that all divided by 36. This one and this one goes out, so we're gonna be left with 3 all over 256 multiplied by 1 over 36 in this case here. So this side we're going to have 9 over 36 n minus 1. This is looking a bit messy. I'm not sure if I did the right thing. Okay, all right, it's fine guys. Let's continue. Oh, okay, I see where I made my mistake, guys. See where I made my mistake. R is not R in this case is a half. Okay, let me remove all that. All that. Remember now, in this case, we're not using the sum, we're just using the pattern as it is. Okay, so the pattern as it is in this case, it was what? So the pattern here, T1, T2, then T3. The pattern here as it is, it was 6, 3, 3 over 2. So our ratio in this case, T2 over that, which is equals to half. Remember guys, okay, that's where I made a mistake in this case. So our first term in this case will be 6. All right, so therefore now they're saying 3 over 256 is equals to the first term, which is 6, ratio which is half to the power of n minus 1. Therefore you divide everything by 6. Apologies about that guys, I could see that something doesn't add up. Okay, so therefore here when you divide, you are going to be left with a half over 2 n minus 1. It's equal to 1 over 512. Right, so with that, what you can do, you can put log on both sides, or you can make this to the power of 2. All right, you can make log both sides, or you can make this to the power of 2. Okay, you can go to your calculator and then do shift factors. There you go. Right, so what you can do, this one here you can write as 2 to the power of minus 1 in bracket n minus 1. Therefore this one here you can write it as 2 to the power of minus 9. Right, so here the bases are the same, therefore the exponents should also be equal. So minus n minus 1 is equals to minus 9. Divide both sides by minus 9 by minus 1 here. Divide by minus 1, divide by minus 1. You're going to be left with n minus 1, it's equals to 9. Therefore you take 1 that side, and it's equals to 9 plus 1, which gives us n, it's equals to 10. Right, and that's how you would deal with a question like this one, guys. If you've got questions on 3.3, I initially made a mistake here, but at least we managed to correct it. So please guys, make sure that you follow the basics and you double check your answers in case you have made a mistake like me. I am Gaston Mapala, passionate about mathematics, right here at Maths with Gaston. Let me see you on the next upload, where we'll be doing question 4. Please give this video a like, share it with your friends, your family, your cousins, and also your classmates as well. If you haven't subscribed, please do subscribe, because this will help the channel to grow. See you in question 4. Alright guys, welcome to question 4. Now let's have a look at this one. It says here f of x is equals to a to the power of x, and then for which x is a is greater than 0, b. It's a point that is given, it's on the graph right there. I am Gaston Mapala, right here at Maths with Gaston, to win with you November 2024 question 4 grade 12. All right, so now let's have a look at a 4.1. 4.1 says calculate the value of a. So we're given here, we need to calculate the value of a. F of x is equals to ax minus 1. Okay, so we're given a point that is on the graph, which is point B, which is 2, is to negative 5 over 9. So what we can do here, we can substitute y there, and then we substitute x where there's x, then we can get the value of a. So let's go ahead and do that. Negative 5 over 9 is equal to a to the power of 2 minus 1. Okay, so we can take 1 to that side, can take this negative 1 to the other side, then we're going to have a squared is equal to 1 minus 5 over 9. Okay, so in order for us to find a, we're going to take square root on both sides, then we put this directly into our calculator. If I put that, what I'm getting is 2 over 3. That is the value of a. Yes, and it is correct, that because they said that a has to be greater than 1, and it is greater than 1. Okay, so we know that that is correct. All right, 4.2 says write down the range of f. Okay, 4.2 says write down the range of f. So you would realize that on the graph, because this is an exponential graph, this one here gives you your range. This one here will give you your range, because why? Is the line of asymptotes, so the graph will never touch this line. So this one gives you the line of asymptotes, so you would know that everything else in the y, which is the range, has to be greater than this value here. No matter which value it is, it has to be greater than this value there, right? So now it means that our y is going to be greater than negative 1, such that y is the element of all real numbers. Okay, there you go, right? And then that will be your range there. Okay, now let's go to 4.3. 4.3, it says that sketch the graph of f, clearly show intercepts, axes, and asymptotes, if any. Okay, so now on this one, guys, what do we have? We need to check if we have the x-intercept and the y-intercept. All right, so let's start. Before we sketch x-intercept, we get it when y is equals to 0. So therefore on the graph, the f of x is equals to 2 over excuse me, 2 over 3 to the power of x minus 1. So if you have a look at this one, guys, we need to make y it's equal to 0, then we look for the x-intercept and also the y-intercept as well. Okay, here we go. I got cut off there a little, but we're back now. So y is equals to 0, it's equals to 2 over 3 all to the power of negative 1. Then take this one to that side, so you're going to have 2 over 3 to the power of x is equals to 1. Okay, so now in order to solve this using exponent, you know that this one can also be written as 2 over 3 to the power of x, and then 2 over 3 to the power of 0, which is also equal to 1. So ultimately this means that x is equal to 0. Therefore x is equal to 0. So when y is equal to 0, x is also equal to 0. So let's check for y-intercept. Y-intercept, we get it when x is equals to 0. So let's come here. Okay, 2. Oh, I like writing 3 over 2, but it's 2 over 3 to the power of 0 minus 1. Anything to the power of 0 is equals to 1. 1 minus 1, it gives us 0. So therefore, there you go. So everything else is equals to 0 here. So our coordinates when x equals to 0, y equals to 0. So we can therefore come and plot our graph here. We can come plot our graph here. Let's there we go. There we go. All right. So now we're gonna have clearly show all the line of asymptotes and also the intercepts as well. So we're gonna indicate the line of asymptotes as -1. This is the line of asymptotes. It's y equals to -1, guys. There you go. But now you need to know if your hour graph is doing like this or like that. The only way to find that one out is to substitute -1 and see if the y value is increasing or decreasing here, or the x value. You need to substitute 1 or also substitute 1 or -1. Okay, so now you can go ahead and do that and check what is the value thereof to see if the shape of the graph is like this or it's like that. So now check if it's like this or it's like that. Okay, so now I already done that. I've already checked how it is. So this is our point here, 0 is to 0. So our function will be looking like something like that. There you go. There's our function looking like that. Then now that is our function f of x. All right, great stuff. So now if you have any question, let me know on the comment section below. Please specify which question you are asking, either 4.1, 4.2 or 4.3. For now, let's move on to 4.4. Great stuff. So now here's 4.4 here. It says if it is further given that C is a point on F where y is equals to 19/8, determine the coordinates of C image, the image of C, when it is reflected along this y-axis. Okay, so now here, guys, you know that if you have got, let me illustrate this. If you've got A and B, okay, and then it is reflected, it is reflected on y is equals to x. So if you have got this, okay, we reflect it on y equals to x. So what happens? X and y, they swap, and then this will be your new coordinate after reflection. Okay, so now let's have a look at this one. Let's check first what is the x value when y is equals to that. So you still remember our function here. It is given by 2/3 to the power of x minus 1. So what are they saying? They are saying our y value is 19/8. So it's going to be 19/8. It's equal to 2/3 all to the power of x minus 1. Then you take the minus 1, that side is going to be +1. And then, guys, here in terms of simplification, I will just move, guys, because you guys are in grade 12 now, so I'm expecting you to do this. So when you take 1 to that side already, so it give us 27/8. Okay, great stuff. So now with that, what can we do with that? We need to simplify further. I'm trying to think here. Okay, so here, in order for us to have the same, this one, it's equals to what? -3. Let me see. Oh, what we can do here, we can say here is going to be 3 to the power of -3 all over 2 to the power of -3. Okay, this here can also be rewritten as, you can come here and say 2/3 to the power of x. This can also be rewritten as 2 to the power of 3 all to the -3. Okay, this is just exponent rule, guys. You can also rewrite it in terms of that. So, or here you can come here and say, okay, the bases are the same, therefore the exponent will be equal, which will give us -3. Therefore, the coordinates of C now will have to be -3 is to 19/8. So now when you reflect it along the y is equals to x-axis, is going to give us an image of, what did I say? We said x and y will swap, so 19 over 8 will become our x, then minus 3 here. So this is our new reflection, right? And that was question 4, guys. Let me see you in question 5, where we'll be doing a hyperbola in that question. So you might want to stick around and watch this question paper until the end. I know a lot of people struggle with hyperbola because it's got 2 lines of asymptote and so forth. All right, so please make sure that you watch the video after this one so that you can fully understand how they ask questions on hyperbola. I am Gaston Mapala. See you on the next one. What's up, guys? Welcome back. This is question 5. Now let's have a look at what this question 5 saying. It's saying sketched below is the graph of f of x. We can already see that it's a parabola, it's a hyperbola, I mean. All right, having a domain of -2, 1, and then domain, they are referring to what, guys? Domain are referring to x values. All right, so this is our domain. Is from infinity to 1 and also from 1 to positive infinity. All right, great stuff. So the graph of f of x cuts the y-axis at 0 is to 1. So it's cutting the y-axis, which is at this point here, which gives us the y-intercept. All right, so this gives us what? Y-intercept. A is a line of asymptotes. Oh, I thought they are actually saying E. Okay, this is a line of asymptotes of f. It's given by that. So this is our straight line there, which is this one here. It's given by that. So we also have got a point here that is not identified. All right, let's move on. 5.1. I hope you guys understand the question. Write down the value of p. So they are requiring us to write down the value of p. So 5.1 are saying write down the value of p. So let's just see here, f of x, a over x plus p plus q. So you can already see p is sitting there, which gives us the line of asymptotes of our vertical asymptotes. So now we already know, so it's here, they've given it to us, it's 1. So therefore it means our line of asymptote, the value of p here, it's equals to -1. Okay, the value of p here is equals to -1. Why is it -1? So that when you solve for x here, it becomes a positive 1, which is our vertical asymptotes there. I hope you guys are aware of it, but if you want to work it out, here is the formula of working it out: minus p. So you just take the vertical asymptote, you put it there. You can just say x is equal to negative, what is the vertical asymptote? 1. So therefore it's going to be -1. So this is how you would solve for it if you were to work it out like that. All right, so now let's move on. 5.2, determine the equation of the horizontal asymptote. So now they want us to find the equation of horizontal asymptote, which is this line here. Okay, so it is therefore they want us to find out this line here. Okay, so 5.2 want us to find the vertical asymptote, which under normal circumstances the vertical asymptote will be given by q, but here we don't have the q, but we already know this asymptote is sitting here. We know the value of x here, and we know the equation of a straight line. So if you were to go to the straight line and substitute x is equals to 1, we should be able to get this point here. Okay, so now we're just going to come here, say g of x is equals to x minus 3. So therefore we know when x is equals to 1, what is it? 1 minus 3, which is going to give us -2, which can make sense. So therefore the equation of horizontal asymptote is going to be y is equals to -2. All right, So that's how you would get this one here. We're just using the equation of a straight line because we can use the hyperbola. Not enough information is provided for the hyperbola. All right, let's move on to 5.3. 5.3 says here, calculate the value of A. All right, the value of A, let's have a look. Come here, 5.3. If you've got a question, guys, please let me know on the comment section below. I am Gaston Mapala right here at Maths with Gaston. If you haven't subscribed, please subscribe to this channel to help us grow the channel. Right, so f of x is equals to A all over x plus p plus q. We already know the value of p, we already know the value of q, so we're just going to look for A in this case. All right, so okay, let's come here and say A, we're looking for A, x minus 1, there is going to be minus 2. So which value can we substitute here? We can substitute this point here that was given, which is point A, when x is equals to 0, y is equal to 1. So we're gonna substitute that point there. So let's go ahead and do that. 1 it's equals to A all over 0 minus 1 minus 2. Right, so now the only thing we need to do now is to solve for y. All right, take 2 to the other side. When you take 2 to the other side, is going to give us 3. It's equals to A all over minus 1. So if you multiply that, if you cross multiply, A is going to be equals to minus 3. Okay, hope you guys can see. All right, 5.4 for which values of x is f of x greater than 0. Okay, so this one, guys, you really need to look at you must look at the graph, but however we need the x-intercepts here. What do we need? Wait a minute. Yeah, we need this value here, guys, which we don't have, which is our x-intercept. It was not given it to us, but when they ask us for the value of x, for which values of x, we must look for the intercepts. So now what we can do is to calculate for the x of the intercept first, because what are they asking is for which values of x is this graph above the x-axis. So you can see already that starting from this point, remember this simply means above x-axis, right? So now if you look at this one, you can see from this point going that side, going that way, I mean, this graph is above the x-axis. So you can't answer this question without knowing this point. So now in order for us to know this point, we must substitute we must look for the x-intercept. So we're going to put the full equation here, minus 3 all over x minus 1 minus 2. So therefore we are looking for the x-intercept. It means y needs to be 0 in this case. So y is 0 minus, I'm moving a little bit fast here, guys. I'm assuming that you guys already know what to do here. Then we take 2 to the other side, is going to be 2. It's equals to negative 3 all over x minus 1. Therefore we cross multiply. In this case, when we cross multiply, this is over 1. You're going to have 2x minus 2 is equals to negative 3. Ultimately you solve for x there. Okay, you solve for x there, then you would realize that x is equals to negative half. Okay, x is equals to negative half. So therefore, to answer this question, you are going to say, therefore, what do we have there? We are going to have x is the element of all real numbers starting from negative half going all the way to 1. But 1 is not included in this case because this graph goes up, but it doesn't go up to infinity. It is restricted by this line of asymptotes here. So you are going to say, starting from negative half, which is here, this graph is above up until it gets somewhere here, but it does not touch that. Okay, so if you were to do this in terms of notations, what are you going to say? You are going to say for all the values that are where x is greater than or equal to negative half. Okay, but however, for the values that are less than 1. Okay, this is how you would express it if you were to do it in terms of the notation. Right, great stuff. So 5.5, it says here the graph undergoes a transformation to H. The domain and the range of the H are the same as that of F. However, the derivation of H is negative on the, okay, they're talking about the derivative on the domain. Okay, so now here in this case, I hope you guys can still remember the transformation you did in grade 11, how to reflect the graphs. So now what are they saying here? They are saying this graph will remain the same. Okay, the domain, which is there, and the range will remain the same. So basically this means if you were to cut this graph here, okay, so what are they saying? This simply means everything else will remain the same. So I'm thinking this graph would look like this. Okay, I'm thinking it's gonna look like that. Please let me know, guys, if what do you think of this one? What do you think of this one? I think yes, it's going to look like that. So if it looks like that, it means what just happened is that we just took this one. Can you see? We took this graph here, then we reflected it here. We took this graph, took it this side, then we took this one, we took this one that side, or took this one to this side. It will just be the same. Or we took this one to this side and then this one to that side. So this will be our new graph here, guys. So what does this mean? It means what basically just happened, they just reflected all these graphs, this hyperbola, across the lines of asymptotes. So we can just say reflect, this was just reflect on x is equals to 1, and then also reflect on y is equals to -2, because everything else remains the same. So it means the line of asymptotes will remain the same, everything else remains the same. But however, it means that our a value in this case is negative, and negatives then is going to become positive. So therefore it means the only thing that they did, they just reflected this excuse me, they just reflected all this along the lines of asymptotes. All right, and that was question 5, guys. If you really want to see question 6, please just stick around on this channel. Go to the playlist excuse me, go to the playlist and then watch question 6. Let's do question 6 together, and let's make sure that we ace this mathematics right here at Maths with Casting in 2025. Let's work together. Make sure that you subscribe, and then let me know if you don't understand anything. Reach out to me also here by dropping a comment or via WhatsApp. I'm always available. See you in question 6. What's up, guys? Welcome back to question 6. Now let's have a look at this question here. It says here that in the diagram below, a graph of f of x, which is a parabola, it is given by minus x squared plus 4x plus 5, and g of x is a straight line as drawn in the diagram below. So we can see that on our diagram below. So now it says here that a c is 3, which is this point here. 3:8 is a point of intersection where EH is drawn parallel to the y-axis with a E as a point of on F and H. E a point on E on point F, and then H on point G. All right, there we go. We have got these 2 points here. They are given to us. We can already see that A and D are the x-intercept of the parabola. So 6.1 says calculate the coordinates of B, which is the turning point of F. So there's the function there, it's given 6.1. The point there it's given of f of x is equals to negative x squared plus 4x plus 5. So we can use this or use the derivative. You guys just use the one you prefer. We can either use f of x prime, which is the derivative, is equals to 0. The answer should still be the same. Or we can use x is equals to minus b all over 2a. So in this case, b is what? It's 4, so it's going to be minus 4 all over 2a. A is minus 1, therefore this gives us what? This will give us positive 2. Therefore you go back into your function, then substitute 2 into that to find the y coordinate of the turning point. Plus 4, 2, plus 5. And therefore this together will give us 9. Therefore the turning point, the coordinates of B will therefore be equal to 2 is to 9. Okay, so similar thing would apply if you were to take the derivative. If you were to take the derivative of that, you're going to get f prime is equal to negative 2x plus 4. Therefore we put this should be equal to 0. Therefore we're going to have minus 2 is equals to minus 4. Divide everything by minus 2. As you can see, the x value here is also equal to 2, guys. So it can either use this method here or you use this one here of the x. Okay, great stuff. Now 6.2 said show that the equation of the line AC, it can be given by that. Okay, so now we need to show that what do we have here. We need this coordinate here, we need it, which is the x-intercept of the parabola. So we get the x-intercept of parabola when y is equals to 0. So f of x for the parabola will have to be equal to 0. So we're going to have negative x squared plus 4x plus 5 is equals to 0. Multiply by negative throughout. Take this negative, multiply by it throughout. Negative 4x minus 5 is equals to 0. Therefore you gonna therefore factorize x, and then for x what are the two factors? We're gonna have plus 1 and minus 5. Therefore x is equals to negative 1 or x is equals to 5. So it means 5 is going to be here at D, and then here we're going to have negative 1 is to 0. Okay, so now that you've got two coordinates, you've got coordinates of A, which is negative 1 is to 0. Then you also have got the coordinates at C, which is 3 is to 8. You can now use analytical geometry now comes in here. You can now use AC is equals to y2 minus y1 all over x2 minus x1. Okay, then we're going to substitute this here. Y2 is going to be 8 minus y1, which is 0, 3 x2 minus into minus 1. Therefore this is going to give us plus 4. Therefore our answer here will be 2. So now therefore you can come here and say use the equation of a straight line to find this straight line, x minus x at c. I'm using x at c because x at c was given, guys. If you want to use this one, you need to be 100% sure that what you did is correct. Okay, so now we can come here and say, okay, y at c is what is 8, and then our gradient there is 2x minus x at c, which is 3. Therefore you can come here and take y to that side. Negative 8 is equals to remove the bracket here, 2x minus 6. Then take y that side here. On the next step, y is equals to 2x, okay, minus plus 8. Y is equals to 2x plus 2. So you can see that they are exactly the same there. Therefore, you can just give them in that way. Say, okay, no, we did show that g of x is equals to 2x plus 2. Okay, great stuff, guys. Now, moving right along, let's move to 6.3. 6.3 here says calculate the maximum length of EH for h greater than g. So they want us to calculate the length here, this length here in between the two curves. So it will calculate the length between the two functions. Please, guys, take note, you need to minus the two functions. Okay, so you are going to start by saying f of x minus g of x. Okay, so what do you have? F of x is minus x squared plus 4x plus 5, all in bracket, minus 2x plus 2. So we're gonna have to simplify this. Okay, this will stay as minus x squared plus 4x plus 5 minus 2x minus 2. Okay, so therefore now here, what do you have? Once you simplify further, we're going to have x squared, 4x minus 2x is going to be plus 2x, 5 minus 2 is going to give us 3. Okay, great stuff. So now if you have this, now this is the function, this is the new function that is expressing this, but you can see that it's a parabola. So at this point here, this is where they said what? Maximum length. So if you know, when they talk about maximum length, it has something to do with the turning point. If they talk about maximum, minimum, it has something to do with the turning point. So it's either here you use the derivative or you use this to find the x value of the turning point. Okay, remember the maximum here, what they're asking you is the y side, but you need to find the x at maximum. So this will be the x at maximum. Okay, this will be the x at maximum. So it's going to be negative in brackets 2 all over 2 minus 1, which gives us positive 1. Therefore, you're going to come back here and say, okay, EH, if you substitute this x value on the original function, what do you get? 1 squared plus, you take this one, then substitute it back here to the original equation, guys. That's basically what I'm doing now. 1, okay, plus 3. This will give us a value of 4. So now you can come here and say, okay, therefore EH is equals to 4 units, because that's what? That is the maximum length. So this is the x8 maximum. It gives you the maximum length of EH. Please don't make a mistake, guys, when it comes to this one. All right, 6.4 said if you are given that k of x is equals to f of x plus m is equals to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5, determine the value of m such that g is a tangent. All right, so now basically here they're asking us for a situation where delta, which is the discriminant of b minus 4ac, is equal to 0. That's what they are asking us. But however, we need to rearrange the equation here. Okay, we need to rearrange the equation here such that everything here will have to be equal to, we need to find a, b, and c. We need to find these things, a, b, and c here. All right, great stuff. So now let's see. First thing first, let's just write what is given there. 6.4, they want us to say km is equals to f x plus m, okay, is equal to that x squared minus 2m minus m squared plus 4x. Okay, I think I'm writing out of the page there, but it's no big deal. I'm just copying this down, guys. Okay, 4m plus 5. Okay, I think I'm gonna come here a little bit. Okay, let me just remove this. Let me remove that. out of the way. Let me just remove this out of the way here. You already know that EH is equals to 4 units. There you go. All right. So now what do you do in this case? What you can do, you can come here and say, okay, therefore g of x, a tangent will occur where the two functions are touching. So it's going to be g of x needs to be equal to k at x. So g of x is what? Is 2x plus 2. It should be equals to k of x is this one here. Okay, so we're just going to write k of x here, x squared minus 2 minus 2 mx minus m squared plus 4x plus 4m plus 5. Okay, little bit low here, down and low, but it's fine. Okay, so what we can do now, we need to rearrange this whole thing. Take this g of x to the other side. Okay, then we can rearrange the whole equation thereof. Okay, so what I'm gonna have minus squared minus 2mx minus m squared plus 4x plus 4m plus 5 minus 2x. This is g of x coming to the other side is equal to 0. Right. So now what do we need to do here? Now what we can do here now, we need to rearrange this. Okay, we need to rearrange this. So what we can do, we can say, okay, minus x squared minus 2mx. Okay, here I'm still fine here. Okay, there you go. Therefore this x, 4x minus 2x will give us plus 2x. Okay, there you go. And then we're gonna have this minus squared there. And then what else? Here you need to be a little bit patient, guys. There's no need to rush. Plus 4m, which is this 4m there. And then okay, now what do we have? You've got this 5x here, and then 2x here will give us what? Positive 3 is equal to 0. Okay, so now what do we have here? Here we've got a common factor here of x. Okay, so you can see, guys, we've got a common factor here. Here we've got a common factor of m. Here where I put the dot, we've got a common factor of m. Here with that star, we've got a common factor of x. So let's go ahead and do that. So we're gonna have minus x squared. Here what do we have? Got minus, we need to remove the x there. We need to remove the x here. It's gonna be x, so it's gonna be 2m x here plus 2, then close bracket. Okay, so therefore here what we're going to take out, we're going to take out m as a common factor. Do we really need to? No, we actually here we don't need to take out anything. We're going to have m squared plus, because here everything has to do with m, there's no x here. Okay, it's equal to 0. So now if you have a look at this, it's a, this it will be b, no, this will be b here, and then this whole thing here will be c. All right, so now we can come and substitute into our discriminant to say that this will be equal to 0. So what is b there? B is going to be given by 2mx plus 2 all squared minus 4. A is what? Is minus 1. Therefore c is in bracket going to be negative m squared plus 4m plus 3. It's a little bit tedious, but it can be done. So once you simplify this whole thing, guys, and okay, remember here I'm just gonna remove that. Here what you can do here, you need to expand this and then simplify this part here. So here you're gonna expand mx plus 2 bracket. Okay, let's see. Okay, 2 close bracket, and then 2mx plus 2 close bracket. So here you can remove the bracket here with this 4 times negative 4. Negative 4 times negative is going to be positive 4. Then you multiply throughout here by remove the bracket like that. Okay, so it's going to be positive 4 times that is going to be negative 4 m squared. Positive 4 times that is going to be positive 16. Yes, m, and then positive 4 times that is going to be positive 12 is equal to 0. Once you finish doing this, you can simplify, and then you can simplify everything here. Okay, so you need to simplify everything here. I hope I didn't make a mistake, guys. Please let me know what you think. Once you simplify further here and everything here, you should get m is equals to, how much did I get? I'm not gonna show that here, guys. I've run out of space. It's going to be minus 2. Okay, please let me know what you guys think of this one. Just one of those questions that are tedious, but we need to show it. But it can be done if you stick to the basis and you know what you are dealing with. I am Gaston Maphala. Let me see you on the next one. We'll be doing this question here, which is question 7 on financial mathematics. Please click on the playlist here on the bottom right, and then you will be able to see question 5, 8 up until question 11 of this paper. I am Gaston Maphala. See you on the next one. Alright, guys, here is question 8. Let's have a look at 8.1. It is a calculus questions here. So 8.1.1, it says here, take the derivative of 3x minus 5x squared in terms of x. So what you can do here, you will just come here. Remember what we are using. We are using this one here as our principle of derivating these equations here. I am Gaston Maphala. Welcome to Math with Gaston. If you haven't subscribed, please subscribe. We solely focus on pure maths from grade 10 up until grade 12. If you're looking for examples, past papers, you will find them here on this channel. Please help us grow. Give this video a like so that YouTube can show it to most different people thereof. All right, so now let's come here and say the derivative of 3x. We are only going to be left with 3, and then here we take down the 2 times 5 is going to give us 10, and then 2 minus 1 is going to be just x. And that's how you would deal with a question like this one. Okay, so now 8.1.2, 8.1.2. so now if you look at this question here, you can't derive this question. It's not you can't derive it this way it is now. So what you need to do now, you need to simplify first, make everything to be on a line. X squared minus 3 square root of, in this case, guys, you must also know exponent rules in order for you to be able to simplify this. So what we can do here, we can say 2 minus, remember when you take it from the bottom, it's going to be minus 2 to the power of minus 2, minus here is going to be x to the power of 7. This one here it's to multiply by 1 over 3. So therefore what you have here, you're going to have 2x to the power of 2 negative 2 minus x to the power of 7 over 3. So that now that it looks like this, now you can take the derivative. Now you can say g of x prime is going to be equal to, now you bring it down here, you're going to say this times that is going to be what, minus 4, and therefore x, this 2 minus 1 is going to be minus 3 there, negative, you bring down the exponent 7 over 3, and then you minus 1 here on top. If you minus 1 there on top, you're gonna be left with x to the power of 4 minus 4 over 3 rather. Okay, so now you can either leave it like this, or you can simplify further and write it like this here. You can bring down the exponent the way it was before. Sorry about that. You can bring down the exponent the way it was before. You can say minus 4, then it's going to be over x to the power of 3 here, and therefore this one here you can just leave as it is because you can't simplify any further. There you go. right? And that's how you would deal with a question like this one thereof. Okay, so now let's have a look at 8.2. 8.2 says determine the equation of a tangent to this function at x is equal to 2. All right, so what are they saying? They are looking for a tangent. Tangent, you know, that is a straight line that cuts the curve only at one point. So now what you can do here, you can say, okay, now let's go and find out what is the y value when x is equals to 2. Okay, so because what we're looking for the straight line function, right? So now you're gonna come here and say, okay, now f of x when it's equals to 2, you substitute it there, is going to be 2 to the cube minus 4 2 squared plus 2, and therefore 2 here plus 3. This will ultimately give us, if I were to punch this into our calculator, it is giving me -1. So these are the 2 points. Is going to be x is equals to 2, and therefore f of x when it's equals to is going to be -1. Okay, so what can we do now? We're looking for the gradient. We already have the 2 points. We're looking for the gradient. We know that number, in this case, you can't use this formula y2 minus y1 all over x2 minus x1. You can't use this formula this time around, guys, because now you don't have 2 points. You only have 1 point, which is what? 2 and -1. So what can you do? But you will remember that if you take the derivative gives you what? It gives you the gradient. Okay, so now if you have got this function like it is here, x squared plus 2x plus 3, if you take the derivative of that, so it will give you what is going to give you the gradient. So now let's go. So you're gonna drop the 3, then -1 there is going to be 2, then 2 drop the 2 times 4, you're dropping this exponent here is going to be 8, then you -1 there is going to be x, then here it's 1, you drop 2 times 1, it's just going to be 2, then you drop the exponent there, 1 minus 1 0, and then anything to the power of 0 is 1, and then the derivative of an exponent is what? Is therefore the derivative of a constant, rather. Listen to me saying derivative of an exponent. The derivative of a constant is 0. So therefore now what is the gradient? The actual gradient. So this here gives you what? Gives you gradient at any point. But we don't want gradient at any point. We want gradient when x is equals to 2. So now you would come here and say, okay, when x is equals to 2, what is the gradient of this function? Okay, then you substitute it there, is going to give us a gradient of -2. Right, so now you have got a point, you have got also the gradient as well. So this one here gives us the gradient, which is equal to m for this function. So therefore you're gonna come here. I prefer using this one at any point in time when I'm looking for the equation of a straight line. I prefer using this. So we do have our point here, which is x is equals to 2, and then y is equals to -1. So it's going to be -1 x -1 there, which is y, and then our gradient we already know it's -2 close bracket, and therefore you're gonna come here and say, okay, what is our x? We know that our x is given as 2. All right, so y plus, now you're just simplifying here, remove the bracket here, binomial -2x, -2 times -2 +4, then you take 1 to that side, so it's going to be y, it's equals to -2x there plus 4 -1, so y is equal to -2x plus 3. So our answer is -2x plus 3. Now that's the equation of a tangent touching at point x is equals to 2. If you have a question, please drop it on the comment section below and let me know what you think of this question. I think it's a really good question, instead of them asking us to derivate from the first principle. But I think that will be the next question. 8.3. 8.3, there you go. 8.3 says here, if you're given this function, determine the f of x prime from the first principles. Okay, so now they're saying if they given us that, we need to determine from the first principle, so which is 8.3. 8.3.1. Okay, so what is the equation? The equation of x prime is given by lim as h approaches 0, f of x plus h minus f of x all over h. Okay, there you go. So now we're gonna have to substitute everything here. Where there's a space of x, we put that. Okay, so lim, you keep writing it, guys, don't forget it. You keep writing it. If you don't write it, you're gonna lose a mark or half a mark, so you must keep writing lim until h approaches 0. So what do we have here? We've got -6. Where there's x, we put x plus h, so it's gonna be squared, minus here into brackets -6x squared. There's a reason I'm putting a bracket, because there's a negative here, guys, so please don't make a mistake. Okay, over h. So we're gonna expand that. So it's equals to lim as h approaches 0. So let's expand that now. X plus h into x plus h. Okay, negative is going to give us positive x squared. There you go. There we go. H. Okay, for now, guys, it's just gonna be algebra. We're just simplifying. So after expanding, you're gonna multiply binomial first times last times first. So now, because you guys are in grade 12, I'm going to allow you to do that. So I'm just gonna have -6 here. I've already done it. It's going to be x squared plus that times that is going to be, how much is going to be 2xh, and then h times h is going to be h squared, close bracket, plus 6x squared all over h. So I'm gonna continue up here. Lim h approaching 0. There you go. Therefore, try to make it easy. Now we're gonna multiply throughout by this -6. Multiply everything with a -6. -6x squared, then 6 times 2, -12x h, therefore -6h squared plus 6 squared all h. Now you can see, now we can simplify. We've got -6h squared plus 6h squared. This one would cancel out. Therefore, if you have a look, we've got h there, we've got h here, we've also got the h at the bottom. So now what you can do now is to take out a common factor of h. So now let's take out a common factor of h. So we must keep writing lim as h approaches 0. So we remove h here as a common factor. We're going to be left with -12x and therefore -6h. Close bracket all over h. H and h would cancel out. As h approaches 0, there is going to be -12x when h approaches 0 here. So this will be 0. So the answer is going to be -12x. And this will be our answer. All right, please let me know what you guys think of this one. If you are a little bit confused, please let me know on the comment section below. All right, so 8.3.2, it says write down how you will constrain the domain of f such that f inverse, the inverse of x is a function. So they like asking this question a lot, guys, a lot. So they just want you to know, you just need to know in this case on which instant will this be a function. All right, so now as you can see there, this is a parabola. This is a parabola. So what you can do here, you can say that, okay, you can say that you just need to know, let's say this is a function. Okay, so in this case, this function, it's like that. So they just want you to know, if you were to constrain this function, actually doesn't touch it touches somewhere here. Okay, it touches somewhere here. They just want you to know, if you were to break this thing apart, how will you ensure that this thing remains as a function? So it's for the, if you were to cut it here halfway, which is what, which is x greater or equal to 0 going that side, and then which part, so it's only gonna take this part here and also that part there, so it's only gonna be less than or equal to. So if you take these 2 points, therefore this will remain as a function when you do the inverse. When you sharp x and y, then you need to constrain it between those 2 points, it will still give us a function. Okay, so 8.3.3, then determine the equation of the inverse for which the inverse is less or equal to 0. So what do you have here? 8.3.3. So this is our function here, y is equals to negative x squared. So I'm writing it in terms of y, so that when we find an inverse, guys, you know what to do. We sharp x and y, then we solve for y again. So let's go ahead and do that. Sharp x and y. Okay, so x will come here, therefore y will go where x was. There you go. And then we're gonna solve for y again. So divide by negative 6, negative 6 and 6 cancel out. It's going to be square root, it's going to be x all over negative that. Therefore you take the square root of everything there, square root there, y is going to be equal to square root of x negative 6. So now can you see that if x is not negative, you're gonna have a square root of a negative number. So what you can do in this case, you can say you are going to constrain it for x less or equal to 0. Therefore this will ensure that all the answers that you have there, they are therefore positive, and then you won't have a negative square root. So as it is here, this was question 8, guys. Let me see you on the next one, where we will be doing question 9. All right, guys, now let's have a look at question 9. It was a cubic function that was given. Let's have a look at this question. A, which is 1:9, and B, which is 5/2:8, are the turning points of a graph. Right? I think you must go and watch a video on this channel that we have that explains all the different kind of questions that they might ask you when it comes to cubic functions. What do you do if you're given intercept? What do you do if you're given turning points only, and also one intercept? All right, and then they say that here we have got C, which is 0:7, which is the y-intercept of the graph, and they didn't give us a function, they just gave us the graph as it is. So let's come here, let's have a look at 9.1. It says, for which values of x is f decreasing? All right, you will remember in analytical geometry, if you've got a function going up like that, it has got what? A positive gradient. Then if it's going down like that, it has got a negative gradient. So therefore this is the one where it is decreasing here, because what? It's got a negative gradient. All right, great stuff. So now let's have a look at on this function. If you have a look at this one here, up here it's increasing until it gets to this point here, where we are referring to it as a turning point here. When it gets to this point, which is our turning point here, on this point, now it starts decreasing up until this point, and then it goes back to increasing again. It goes back to having a positive gradient. So therefore in between here, what is happening? in between here, between these 2 points where x is equals to 1 and where x is equals to 5 over 2, our function is what is decreasing. So for all the values that are greater than, for x greater than 1, okay, and then for x less than 5 over 2. Okay, so you can also write it in terms of this x greater than 1 or x less than 5 over 2. You can also do that as well, right? 9.2 says write down the x-intercept for f of x, the derivative of. Okay, now what do they want? They want us to write the x-intercept values, okay, which is the derivative of that. Okay, so now in this case, what do they want? They want us to write the x-intercept, which is the derivative of those. Okay, they're saying the derivative of f. So in this case, guys, they've given us these two values here. Write down the x-intercept. They've given us these two values here, which is, so if you were to take the derivative of this function, to make a parabola, a derivative of this, remember this is f of x is equals to ax cubed plus bx squared plus cx plus c. Okay, so if you take this, a derivative of this is going to give us what? A derivative of that is going to give us, I'm taking a derivative, guys. I'm assuming that at this stage of the exam, or at this stage of the term, you should be able to do this. So this gives us a parabola. So what can we do? What can this be for this to be the intercept values? So it means our parabola, it means our function will have to be like this. This will be our function, guys, with these two values here, which is the x-intercept. So therefore our x-intercept will therefore be x is equals to 1 and x is equals to 5 over 2. All right, you obtain this when the derivative is equal to 0, guys. All right, so which is our new function. Okay, this also on the cubic, you obtain them when the cubic function is equal to 0. All right, I mean the derivative is equal to 0 rather. Okay, so I hope you guys fully understand. Now let's move on to 9.3. Right, 9.3, it says here, for which values of x will f be concave up? Right, so for which values of x will f be concave up? Okay, guys, so now let's have a look at this one. You have got a starting from here, but by just looking at it, this is concave down, guys. This is down up until a certain point here. Now up until this point here, this graph starts to concave up like that. And guys, you will remember this point here is known as the point of inflection. This is what? Point of inflection. But in this case, we get this point when the second derivative is equal to 0. But in this case, we don't have the equation, so we won't be able to do that. However, it is worth noting that this point here, this point that we are referring to here, this point of inflection, it's halfway between this x value and this x value here. So this point of inflection is a halfway this point here. So what do you do? Because you are looking for this point here to say, starting from here, going that side, our graph is concave up. Okay, so this is what you would do here in this case 9.3. This is what you do. You will say that point, which is the point of inflection, is going to be halfway between these 2 points. So you're going to just add them together and take a half, which is like a midpoint thereof. Okay, so what you're gonna have here, if we add this together, we're gonna have 7 over 4. So now our answer will therefore be anything that is above this point. This is 7.4, 7 over 4 rather. So anything above that is concave up. Okay, so anything above 7 over 4 is concave up. Okay, 9.4 says determine the values of k for which y is f of x plus k will have 3 positive x-intercept. So basically in this case, guys, what are they saying? They are saying that if you were to move your graph, this is what they're asking you, move your graph by a certain constant, which is k. So move your graph in such a manner that you will have 3 x-intercept. It means your graph has to come and touch the x-intercept 3 times. So if let's say for an example, if we were to move it here, it's still not touching the x-intercept. And then if I were to move it here in the origin, let's have a look. It's touching the x-intercept here. It's also touching the x-intercept here. It's also touching the x-intercept there. Okay, so even if we try to move it a little bit lower, it's gonna touch there, and then also touch again here, and therefore touch again there. So you are looking for 3 positive. Okay, 0 can be positive, so they said positive, so we are looking for these 3 points here. So now what would you do in this case, guys, to make sure that you get this value here? Okay, so if you are here, you would move it by a certain value. We're going to say y is equals to f of fk. We are moving it down, so this downwards movement, it's affecting what? It's only affecting the y values. So it's gonna move down, and eventually when it gets somewhere here, it's going to start affecting the x values. Okay, so if we move it down up until this point here, you can see that we would have moved it, this turning point, the point of A. If we were to put the point of A here, we can't allow it to be 0. We can't allow A to have a 0 value here on the y-axis, because now it's going to touch twice. Okay, can you see that it's going to touch twice? If we were to move this thing down again, it's going to touch twice. Oh, all right, I'm removing my curve now, or maybe let me just put it in a different color for the sake of understanding. Here we go. So if this one here is the one that is correct, it's touching 3 times, and then our is positive. So now how do we do this now? To restrict this value here, we know that x is going to be 1. Okay, but we can't allow this. So it means we can drop it by 8, but it can never be -1, because if you say -1 here, is going to be 0. All right, so we know that is going to be 1. It's going to be 1:1. Okay, so which means that we have dropped it by 8. Okay, so and then what else do we need here? We also did need this point here has to be so low. This one, it has to be low, but it cannot be that this point here it's less than 8. I mean it's more than 9, so we're gonna drop it by 9. But here we don't have 9, because it's gonna be what? -1. But because we're dealing with a distance in this case, I'm moving from 1 2 3 4 5 6 7, then 8 is here, and then 9 is here. Can you see? Moving the graph downwards. So already in this case we can see that, okay, our k has to be a negative number, so it's going to be -8 here in this case. All right, so now we have to put the values that the values of k that will allow us to have 3 positive x-intercept. Okay, so now in this case we're gonna come here and say negative k has to be greater than 8, okay, and then but less than 9, which is the distance. But however, we're looking for the k, so we're gonna divide everything by k. k negative 1, and then k negative 1 here. Positive, positive. You have to remember that if you do the inequality, it's going to face the other way around. So inequality will face the other way around here in this case, and therefore also in this case. So this is the kind of equation that we have. Then we can just rearrange our inequality to make it look proper. So negative 9 greater than k but less than negative 8. Okay, there you go. That will be our answer. Please let me know what you think, guys. There's many ways of doing this, but I chose this one. I know it might be a little bit tedious, but I felt like it was the shortest route to do this. But if you would like to calculate it, or you've got another method, please let me know on the comment section below, and I will be glad for us to discuss it together via WhatsApp, or you can reach me out. My number is there on my bio. Please subscribe, share this video with your friends, your classmates, your cousins, and everybody that needs it. I am Gaston Mapala. See you in question 10. Alright, guys, here we are. We're back at question 10. A cyclist, by the way, guys, if I'm not doing mathematics on my spare time, I normally enjoy cycling. I've got a road bike. I do cycle a lot. Yeah, today I'm recording this with my daughter. Please don't mind the noise in the background. Let's read the question. It says here, the cyclist rode from town P and then stopped at town T. The speed in kilometers per hour at which this cyclist rode is represented below. So this is our formula here. As you can see, it's a derivative. It means they have derived this question from the distance. All right, let's go on and say, they said that please note that the speed is the rate of change in distance with respect to time. All right, and those of you who are doing physics, I think you'll be familiar with this one, the rate of change in distance into time, which is what gives us this kilometers. Distance is in kilometers, into time it's in hours. All right, so let's do 10.1. 10.1 says calculate the maximum speed that the cyclist reached on this ride. All right, so now the speed maximum, I've already told you guys, every time you hear the word maximum or minimum and we're dealing with derivative or we're dealing with functions, you must just know that they want you to equate the derivative. They want it to be equal to 0. So in this case, they're asking us to calculate the maximum speed. So they've given us S, which is that. But however, guys, can you see that this is what? This represents the speed, okay? So this equation represents the speed, but however, we can't say that what are we looking for? We're looking for the maximum speed reached. So we need to get the maximum time. So what do you do now? We must take out the second derivative and equate it to 0. So second derivative, you're going to bring down the 2 here, is going to be negative 3 times 2 into that, 2 minus 1, and then here we're going to have what? 18 is going to be t1 minus 1. So here is as good as, let me put it nicely here for those of you, let me say times 1, t1 minus 1. So now we're going to simplify our derivative. In this case now is going to be equal to negative 6t plus 18. Okay, so this will have to be equal to 0. Okay, this is the same thing that you would do if you were doing, let me see, if you were doing a cubic function and they ask you for the maximum point of inflection. So this is what you would calculate. So this is the second derivative is equal to 0. So we are looking for the maximum, the time it took to reach that maximum speed. Okay, so negative 18, take 18 to the other side, gives us negative 18 divided by negative all over negative. There's cancel out. T is equal to, is going to be 3 hours. Okay, so this is the time it took to reach maximum speed. So therefore, after this, guys, we're gonna take this time, maximum time it took to reach maximum speed, to substitute it back into the original equation to find the original speed. So therefore it means S, when t is equals to 3, is going to be negative 3 squared. We're substituting into the original equation of the speed is equals to 3. Now we're gonna go ahead and punch this into our calculator, then we'll find out that maximum speed, which is reached at 3 hours, is going to give us 27 kilometers per hour. Okay, and this will be that our max speed. Okay, so this will be our maximum speed, guys. Right, great stuff. So that's how you deal with that one. So let's come here and say calculate 10 point. This is what 10.2. Calculate the distance between town P and town T. Okay, so now they are asking us to calculate the distance between town T and town P. So now it means if this cyclist started here at town P, they will ride their bicycle, ride their bicycle and reach point that they reached maximum speed, which is this maximum speed here, in what? In 3 seconds. In 3 hours rather, not 3 seconds. Okay, so now they want us to calculate the total overall distance. So now you need to calculate the total time it took for this cyclist to reach the end. So what can you do? What you can do in this case, it's either we can work out the total time, or the total traveling time, not the time it reached to reach maximum speed, but the total traveling time. So therefore this total time, we will get it when the speed is equal to 0. So it means this person starts here, and then the speed here is equal to 0, speed is equal to 0 here, and also the speed here is equal to 0. But we also understand that before this person starts riding, the time is also equal to 0. So it means there's also a time here when this person reached the destination. So this is basically what we are looking for in this case. So we're gonna come here and say, okay, negative 3t squared plus 18t is equals to 0. So we're gonna remove a common factor of t, in this case minus 3t plus what is gonna be 9. Is it 9? Oh, sorry, excuse me. It's gonna be plus 18 close bracket equals to 0. So t is equals to 0, or also negative t is equals to negative 18 divided by negative 3 divided by negative 3. T is equals to 6 hours. So this is our t total, guys. It's equals to 6 hours. This is the total time it took for the ride, total riding time, ne? Okay, so this is the total time for the ride. So now once you have this, we need to get the distance now. But remember, they said this is, please note, the speed is the rate of change in distance with time. Okay, so now with respect to time, so now we can derive this one backwards. Let's see, st we need to derive this one backwards is equals to negative 3 t squared plus 18 plus t. So if we were to derive this backwards, we're going to have s, which is our distance. Then we're gonna multiply backwards, guys. So we're gonna take this one backwards. So it means this 3 is gonna come here. We're gonna add 1 there. It's gonna be negative. It's gonna be negative t. We add 1 here plus 18. No. This was 18. It was 9 times 2. So we're gonna take it backwards. Is gonna be 9t squared. Okay, so guys, with this you can see already that what you have here, is, if you were to derive this, you'll go backwards here. Okay, so if you were to take this, okay, don't mind, that's my daughter, guys. She also wants to do mathematics. Excuse me. All right, guys. So now, welcome back. So now, if you need to go backwards, it's gonna give us that. So now we already have what we see here as a distance. So the maximum time it took. So we're gonna substitute our t, which is this one here. We're gonna substitute it into this equation here. So we're going to have negative is going to be 6 cubed plus 9 3 squared. This will give us the maximum distance, which is going to be 180 kilometers. So this cyclist really traveled 108 kilometers. That was the distance between two different towns. Have I ever done this distance before? Yes, of course, guys, I have done this distance before while cycling from where I stay to a different town. I am Gaston Mapala. Let me see you on the next question, where we'll be doing question 11.